Okay, let's have a go at this question involving finding the equation of a straight line, and that straight line is part of a right-angled triangle that's formed by these coordinates here. So I think the first job is to mark up these coordinate points on these axes here and find out what's going on. We've got A at -2, 1. B, they say, is 6, 5. Now C, we've got a problem. We don't know the y-coordinate of C, but we do know the x-coordinate. So C must be on this line here somewhere. But now we're told ABC, AB and this mystery point C is at a right angle. So let's pop in AB to start with. And now I'm supposed to draw a right angle to that line. It might be there. So this is now the point C. And we can put the last line in here to complete our triangle. So there we are. Do remember that point C is just drawn to a point approximate to where it should be. Okay, so we know that's the right angle. Now let's start looking at the problem. Find an equation of the line that passes through A and C. Right, so the question needs us to find the equation of the line. Luckily, we know a coordinate through which it goes, so that's going to be very good. So to form that equation, we need to find both M and C, neither of which we can pull off the diagram because the diagram is inaccurate because I guessed the position of C. We've got to work out where that position of C is. So how are we going to do that? Well, it's all to do with gradients. As so many of these questions are, it's all to do with gradients, because if we can find the gradient of this line, then the gradient of this line is the negative reciprocal of the gradient of the line AB, because we're told that BC is at a right angle to AB. So gradient of AB is the rise over the run. Now, going from A to B, we've climbed from 1 up to 5, so that's a rise of 4. And going from -2 to 6 is a run. -2 up to 0 is 2, and the rest is 6. This is 8. So this gradient is a half. So therefore, gradient of, this is BC, is the negative reciprocal of this guy, which is -2. We just turn it upside down and make it negative. So we know the gradient of this guy. So if we now just compare the coordinates from here to here, in terms of rise and run, we can set that equal to -2. So therefore, the gradient going from here to here, k minus 5, is the rise, and the run, we have to do it the same way, is 4 minus 6. And that's equal to -2. 4 take away 6 is -2. So we get k minus 5 is equal to 4. Therefore, k is equal to 9, adding 5 to both sides. So the coordinates of C, as calculated, are 4, 9. How right were we? Well, not bad. My estimate of a right angle wasn't too bad. It does indeed go through the point 49. But we're still left to find the gradient of AC. So let's start by finding M. M is found by the rise over the run. So I can say gradient of AC. The rise, well, the rise is from 1 up to 9. So that's a rise of 8. And the journey from here to here, the run, -2 up to 4 is +6. So this is 6. This cancels down to 4 over 3, which is equal to M in the equation up here. So all we've got to do now is find C. And C is found by substituting one of the points, let's choose A, into the equation and solve for C. We get 1 is equal to 4/3 multiplied by -2 plus C. And we've got to solve for C. Therefore, 1 is equal to negative 2 times the 4 is negative 8 over 3 plus c. As we're over 3, this guy in over 3 terms is 3 over 3. So we've got a positive 3 over 3, and we're going to be adding 8 over 3 to it. So therefore, c is equal to 11 over 3. So our equation becomes, so AC is y is equal to 4/3 x plus 11 over 3. Now, is 11 over 3 feasible? 11 over 3 is 3 2/3. Yeah, okay, yeah, just above halfway. I'll go with that. The diagram again is proving reasonably right. Now they want the answer in the form ay plus bx is equal to c. So c we leave on this side, and we've got to move the 4/3 x across. So we get y minus 4/3 x is equal to 11 over 3. But we're still not quite done, because the question wants integer answers for the coefficients of y and x. So I'll take this equation and multiply through by 3. So I get 3y minus 4x, the 3's obviously cancel on that particular term, is equal to 11. And if we're being really fussy, that gives me that a must equal 3, b must equal negative 4, and c equals 11. And that is the answer.